Hi everyone, I'm going to do some example solves for 7Simul, 7SimulFlip, and regular flip, because those are the main methods I use. And I'll give a brief explanation about when I use each method, how to do each method, and the scenarios in which you should use them. And I'll explain what I'm doing in each of the solves. All the resources with the memos written out and such are going to be in the description, as long as the Scrambles as well. So on this Scramble, there's no lucky cases at all. So I'd do 7SimulFlip. I'd just start memoing in one orientation, and if the ticks are really bad, then I'll switch to another one. So I'll give a brief explanation about how memo works for this. So first, we start with dr to r, which is just 2, and then add that to u to l, which is 3. So we get 5 as our first number. Without flipping over, we do L to UL, which is 4, plus R to D, which is -1. So we get a total of 3. So our first two numbers are 5, 3. Then we flip back, and then measure the distance from U to C, which is just -2. So our first three numbers are 5, 3, -2. And so without flipping over, this is a slash memo. This is kind of the hardest one. So the way I do this is, instead of just doing a bunch of calculations, you kind of just see what distances are between two clocks and then just add them when you need to. It takes quite a bit of practice, so make sure to rewatch this if you need to. I'll provide an example solve for 7Simul too when I get to that. But this is just regular 7SimulFlip. But the memo is the same. So we start by measuring the distance from U to UR, which is -4. And then, so keeping -4 in mind, we apply -4 to the center clock, which would get us to this upper corner, right where my finger is. And then we then measure the distance between the bottom clock and where my finger is now, which is -3. We flip back over. We apply -3 to the L clock, which would put my finger here, and then we measure the distance between UL and U, which is 0. And so we apply whatever the difference would be, in this case it's 0, to this right clock, and so we get -5 as our fourth number. And then for our last one, you measure the distance between C and U, which is 1, and then apply 1 to this bottom clock, so you get -5. And then we we just keep -5 in mind, and then we measure the distance between L and UL, which is 4. So we add -5 and 4, we get -1. And then we add -1 to R to DR, which is -1 as well. So we get -2. So our memo is 5, 3, -2, -5, -2. So the way execution for 7SimulFlip works is you match this middle clock to the bottom clock, and then do the first memo number on the other dial, which is 5. Put the L pins up, match the edges by moving the block we already made to this one on the right, and then match this corner to the rest of the block. And then we put this pin up, and then do the next two. We do the 3 on the up pins, and then -2 on the down one. Then we flip, put this pin up, and then we'll just execute the next two moves, which are -5 and -2. Only UL up now. The finish is kind of the same for 7Simul here, so it'll look similar if you keep watching. And then we make a block here with the UL pin and match these. Match the corner with the rest of the block here. Put L pins up now. Match the edges to the rest of the block. Make a cross. Then we match the bottom right corner. And then we have this sort of thing. And then we just align both to 12. And it should be solved. Okay, so I'm going to do another 7SimulFlip example solve. This time it's just going to have edge-to-edge lucky case, which I would study 7SimulFlip for. So when I have an edge-to-edge lucky case like this, I'm going to put it in the front like where I start, because when you're executing on the second side, you can essentially check like if you've solved it and executed it correctly. I'll explain that a bit later, but we'll just memo as normally. I'm just going to go through this one a bit faster because I explained it in the last one. So you have DB6A, DB6AA. So I'll show you like the first few, but I'll go over slash a bit later in 7Simul as well, so you can get more of the hang of that. So 1 plus -5 is -4, and then cost -4 to go here, and then 2 to go here, which is -2, and then 6 from here to here. So those are the first three. Slash, I'm not going to explain again, but you get the gist of it. Execute it the same way. Or flip, -1, -1. And this is where the move skips from the edge-to-edge case. So if you did your memo and execution right, this will be solved. So you'll skip a move here instead of at a different point in the solve. Okay, so this is going to be the 7Simul example solve. I only do this when I get center to edge skips like here, where we have 2 matching. 12 is going to be on the right for this one because it skips a D move. So I start memoing from this side. So 7Simul works a bit differently for memo. I'm going to send a memo real quick. 6. Okay, so we start by measuring the distance from D to C, which is just 6, as it takes 6 ticks to get to here. And then the next one's an addition of 2 different movements. So we have R to DR, which is -5, plus L to U, which is -1, so we get 6 again. And then we flip back and we just measure R to D, which is just 2. And then we do slash as normal, except when we measure the distance between U and UR, kind of brings this clock along with it to here. So I kind of visualize this as skipping a step, but it doesn't really make a difference. So my finger's now here. We now memo the distance that it takes for this clock to get to where my thumb is, which is 4. And then 4 gets us to where my thumb is here, and it takes -5 for this top clock to get to here. And so -5 we remember, and we apply -5 to here, and so we get -4 for our 4th letter. Next, we measure the distance from center clock to the top, which is -4. Apply -4 down here to get -1. And then from U to UL, it's just 1, and then from R to DR, it's also 1, so we get 1 for that one. So our memo is 662, -41. We flip after we memo, and then we execute. So we do the first 2 in a pair, so we have 6, 6. And then we put this pin down. We match these edges here to get this little block. And then we do the 3rd letter, which is 2. And then we put down the top pin, and we just match the corner to the rest of this. You would also, if this wasn't solved, you would do the D move, but since I only use 7Simul, I will never have to do that move, so that doesn't really apply. And then we do the slash, which is -4, and then 1, and then we match all these edges together. And this is kind of the same as 7SimulFlip. We match this corner, and then we match the edges here, and then match this corner here, and then we just align everything to 12, like that. So I'm just going to do a few more example solves. I'm not going to go into detail with memo. I'll just say the memo, what method I'm doing, and why. So there's no skips here, so I'm just going to do 7SimulFlip. Okay, so I get CA5AC, so we do C, and then match these with intuitive step, A5, so we do -1, 5, flip, this pin up, -1, -3, match all these edges, match that corner, align, solve this corner, align everything to 12. Okay, so this is a scramble I would actually do flip on. I'd probably start from this side because I normally start with UL, and my pin order, it's kind of harder for me to start with UR on the second side, so I just prefer to start with it on the first. So there's no lucky edge case or edge skips here, so I'd kind of just do this normally, where I just make a line here, put another pin up, your normal flip, yada yada. I leave this pin down so I can transition to the next side better, but I'd also push this pin up on the way because I know it's a line, so I can just go straight into it. And then I switch over. I would do a diagonal skip to skip both these corners, or skip one of them, and solve the other one at the same time. And then solve this one here, solve this one like that, and then AUF. So that's like a brief explanation / tutorial for all the methods I use and kind of what situations I'd use them. I kind of gave an explanation for the memos and everything else. Let me know if there's any information you'll need. I'll be happy to answer your questions. Yeah, that's pretty much it. See you.